In previous lecture, we had started with inheritance. Inheritance helps in code reusability. The child class can inherit all the properties of parent class. Also, we had started with an example. This was the program in which there is a class named base and there is a class named derived. Derived class wants to inherit all the properties of base class. All the properties of base class. And also derived class have its own properties also. Also, we had discussed that to inherit base class, after the derived class, the child class which want to inherit all the properties of base class, you will use colon, the public specifier and the parent class name, where in this case the parent class name is base. So this means that derived class is inheriting the base class as public. We can inherit base class as private also and protected also. So what does this mean? Inherit base class publicly. It means that whatever is private in base class will not be accessed because that is private to the base class. So this derived class cannot access that because that is private to the base class. So here I and j are private to base class. So it cannot be accessed by the derived class. That means derived class cannot inherit the private properties of the base class. Let it be data member or a member function which is declared as private, the derived class cannot access it. Then whatever is public will be inherited as public in derived class. So whatever is after here, this set function, the show function is in public section. So whatever is public will be inherited as public for derived class. If I will use private here, if I will inherit the properties of base class as private, that means whatever is private, the derived class cannot access this. This is the strict rule. Anything which is private to the class cannot be accessed by anything outside the class. So derived class cannot inherit the private properties of the base class. But whatever is public will be inherited as private by the derived class. The set function will be private in the derived class and show function will be private in the derived class. Though it is public in base class, but it will become private in derived class because the properties of the base class are being inherited as private. If I will use protected, that means whatever is private, the derived class cannot access it, cannot inherit it. And whatever is public will be inherited as protected inside the derived class. So here's the table given in the textbook that this is about base class. So a base class can have its properties public, private and the protected. So this base class can have its properties as public, private and protected. Here these two properties are private. Here the set function and show function is public. Or you can say if it wants to have anything as protected, it can use protected access specifier and it can declare the function as protected. Okay, some body is here inside this. So a base class can have its properties as private, where there is nothing, by default it is private, public and protected. So a base class have its properties as public, private and protected. And inheritance control or derived class, the derived class can also have private, public and protected. This derived class can also have private, public and protected. But what does this means with reference to inheritance? So let's see. This is all about base class. If we'll have to understand this table in vertical form. Okay, in vertical form we will understand the meaning of this table. So whatever is public in the base class, like here in the example, whatever is public in the base class will be inherited, or you can say that if you inherit the properties of base class, or if the derived class inherits the property of base class as public, if the derived class inherits the properties of base class as public, then if derived class inherits the properties of base class as public, then whatever is public will be public, private is not accessible, and whatever is protected will be protected. Here I had told you, if the base class will inherit if the derived class will inherit the properties of base class as public, then whatever is private, it cannot access it. Derived class cannot access it. So the derived class cannot inherit it. But whatever is public will be inherited as public in the derived class, and whatever is protected will be inherited as protected. Okay? Then if the derived class inherits the base class as private, if the derived class inherits the base class as private, then whatever is public will become private, and private members of the base class is not accessible, and whatever is protected is private. So what it means when we talk with reference to the program, so if this derived class will inherit the base class as private, then what happens? Whatever is private in the base class is not accessible. So as you can see, whatever in the base class is private is not accessible. Okay, and whatever is public will be inherited as private in the derived class. It will become whatever is there in the public section, like the set function and the show function, will become private in the derived class. And whatever is declared in protected, here put function, will be inherited as private class. It will no longer be protected in the derived class. It will be inherited as private. This put function will become private in the class derived. Then we'll talk about protected. Which means if the derived class will inherit the properties of base class as protected, then what happens? It's very common that private properties of the base class are not accessible, and whatever is public will be inherited as protected, whatever is protected will be inherited as protected. So with respect to this, if this derived class will inherit the properties of base class, as protected, then of course private members are not accessible. The private members will not be inherited by the derived class, and whatever is public, like here in this example, set is in public and show is in public, will be inherited as protected, and whatever is there in the protected function, protected, whatever property is in the protected will be inherited as protected only. Okay, so I hope this table is clear to you. Let's see what's written here. So the type of inheritance influences the access rights to elements of various superclasses. So that's what we have discussed. The type of inheritance, if the type of inheritance is public, if the type of inheritance is private, if the type of inheritance is protected, so that influences the access rights of the properties of the base class, or you can say superclass. Okay, that's what it is saying. The leftmost column, this it's talking about this, the leftmost column lists possible access rights for elements of class. This means the leftmost column lists possible access rights for elements of, you can say, superclass or base class. It also includes a third type, protected. This type is used for elements which should be directly usable in subclasses but which should not be accessible from the outside class. So I have already discussed about the protected class in previous lectures. What is protected is, I'll tell you. If anything is private to a class, then anything outside the class, when anything is private to a class, if the data member or member function is private to a class, then anything outside the class cannot access the private members of a particular class. This we know. If this I and j is private to base class, then anything outside this class cannot access the private members of this base class. This we know. But what if I want that there should be some data member, for example put function, or in other terms what I can say here is anything private to the base class will not be accessed by the derived class and also by the main function. Okay, anything private to the base class cannot be accessed by the derived class and cannot be accessed by the main function. But any member which is protected, like this put function, if derived class wants to access the protected member of a base class, then it can access it. But if main function will try to access this protected member of a base class, then main function will not be able to access it. So what it means, what's the difference between private and protected is anything which is private to a class will not be accessed by anything outside that particular class. But any member function which is declared as protected, then anything outside the class cannot access that protected member until and unless it is a child class of the parent class, or it's a derived class of the base class. So if derived class wants to inherit the protected members of the base class, then the derived class can access it. But anything or other than the child class, nothing can access the protected members of the base class. So that's what it's trying to explain here, that it also includes a third type, protected. This type is used for elements which should be directly usable in subclass. So here this subclass, this derived class is a subclass. So this subclass can access the protected members of the superclass. But other than the subclass, like this main function, cannot access the protected members of the base class. So protected access specifier is mostly used in inheritance. So this type is used for elements which should be directly usable in subclasses but which should not be accessible from the outside. Thus, one could say elements of this type are between private and public elements, in that they can be used within the class hierarchy rooted by the corresponding class. Okay, so that's what it means. So the protected falls between private and public. In general, it is good practice to make data members private. So what it is saying is, in general, we should always declare the data members, like here I and J, should be declared as private. Member functions that must be called from outside the class should be public, and member functions that are only called from within the class should probably be private. So what it is saying, if this function is a member of class base, and if I will declare the show function as private, if I will declare this show function as private, and this set function is a member of base class, and this show function is a member of base class. So if this set function wants to invoke the show function, it can do so, because though it is private, but this set function can access it. The set function can call the show function. The set function can access the show function, because set function is a member of a class and show function is a member of a class. So the member of a class can access the private members of that particular class. Okay, so that's what it is saying, is that the member functions that are only called from within the class. So here the show function is called from within the class, which is set function. Set function is calling the show function. So show function is called from within the class, should probably be private. So that's why, just for the sake of example, I have defined this show function as private. Okay. Then, thus, in addition to speeding development time, proper class construction and reuse results in far fewer lines of code, which translates to less bugs and lower maintenance cost. So code reusability is possible because of inheritance. Fewer lines of code means less error in the program, less bugs, and maintaining the program will cost us less, lower maintenance costs. Now, different forms of inheritance. There are different forms of inheritance which we will be learning, but let us first talk about the output of this program. Now, here in this program have two header files, a class whose name is base, and there is another class whose name is derived. And this base class have its own members, or you can say have its own properties. Then this derived class have its own properties. Okay, and one more thing, this derived class is inheriting the base class as public. So whatever is private, this derived class cannot access it, but whatever is public will be inherited as public, Okay, then the main function. The execution of the program always starts from the main function. Let us see what is there in the main function. In the main function there is CLR SCR, which is clear screen, which clears the output screen. Then it has derived OBJ, OB. That means here is a class name which is derived, and here's the object name OB. So this means here we are creating an object of class derived. So this is instantiation of a object. We are creating an object of class derived. So this object, as soon as we will create an object, constructor will be called. And since we are passing one value to the constructor, that means the constructor it is going to call is parameterized constructor, which will have one parameter, and that parameter will have data type int, because this value is int. I am passing integer value. So in derived class there should be a constructor. Here is the constructor. It is having a constructor which has got one argument, and that argument is having data type int. So 3 will be passed to x, and there is a data member of class derived which is k is equal to x. That means 3 is passed to x, so x is equal to 3, and k is equal to x means k is equal to 3. We know that constructors are used to initialize the data members of the object. So k is the data member of the object, and we have initialized the data member of the object, which is k is equal to 3. So for OB, k is equal to 3. Now next what we see is OB dot set 1 comma 2. Where is the set function? Set function is in base class. So why the object of derived class is accessing the set function? Because this derived class has inherited all the properties of base class except the private class, because derived class cannot access the private members of base class. Except private members of the base class, derived class has inherited public members of the base class and protected members of the base class. Since this base class do not have protected members, it has only public members. So whatever is public in the base class is inherited by derived class. That means the set function is also available in derived class. That's why the object of derived class is able to access the set function of base class. That's why OB dot set 1 comma 2. So 1 is passed to A and 2 is passed to B. where I is equal to A and this J is equal to B. So this set function is initializing the data members of the base class. Okay. So this the process of the function got finished. It will be back here. Next, this object, the object of derived class is trying to access the show function. Where is show function? Is it in derived class? No. Is it in base class? Yes. This is in base class. So this show is a member of base class. Then object of derived class. Why object of derived class is able to call the member function of base class? Because this derived class has inherited all the public members of the base class. So that means the show function is a member of derived class also, because derived class have all the properties of the base class which are public. Okay, that's why the object of derived class is able to access the show function of base class. So what is there in the show function? Let's check. In show function you will see the cout statement. So in cout statement, it's going to print something on the output screen. It is going to print the value of I. What is the value of I? I is equal to A. A is how much? 1. 1 was passed to A and I is equal to A. So I is equal to A means I is equal to 1. So on the output screen, what you will see? 1. And in double inverted commas there is a space, so there will be a space. After that you will see j. Value of j is how much? 2 was passed to b. J is equal to b, which is 2, so j is equal to 2. So this is going to print 2. Now end of the line. The next line which will get printed on the output screen will be on a new line, the end of the function. So it will be back here. After this object of derived class is trying to invoke show k function. Let us see, is there a function show k in derived class? Yes, there is a function show k in derived class here. So what is there in the show k? There's a cout statement. The cout statement will print the value of k. What's the value of k? When we had created the object ob, 3 was passed to this x and k was initialized to the value of x. So x is equal to 3, k is equal to x means k is equal to 3. So in show k, what is there? The value of k will be 3. So what is going to print on the output screen? 3. Then the next line which will be printed on the output screen will be in a new line. Then the end of the function, it will be back here, get ch, end of the program. So this is the expected output. The purpose of this program was to explain how the derived class can inherit the base class as public. Base class access control publicly derived class. Okay, so the purpose of this program was to explain how we can inherit, how the derived class can inherit the properties of base class as public. Derived class cannot access the private members of the base class, and whatever is public will be inherited as public, and whatever is protected will be inherited as protected. Okay, so different forms of inheritance. What is different forms of inheritance? It means in how many ways we can perform the inheritance in C++. C++ supports single and multiple inheritance. Single and multiple inheritance means there is one child class. This child class will have only one parent class or superclass, you can say. Okay? And multiple inheritance means a child class can have multiple parents, 2, 3, 4 parents. So a child class can have multiple parents. That's why that is known as multiple inheritance. This is very important topic from exam point of view. Multiple inheritance in C++ is the ability to have two or more base, or you can say parent classes. So multiple inheritance has the ability that the derived class can inherit the properties of two or more base classes or two or more parent classes. The benefits for the user would be to create objects which would have the characteristics of both of its parents or base classes. Okay, so that's what it means. The single inheritance. Single inheritance means derived class has only one direct base class. The derived class have only one base class. Create complex hierarchy of classes, graphs. Create simple hierarchy of classes, trees like one child, one parent. One-to-one inheritance of members. That means this derived class will inherit all the properties of base class. Specializes a single base class. That means I told you that this is the base class, the parent class known as generalization, and derived class is known as specialization. Here I had told you. Subclass is said to be specialization and superclass is known as generalization. So this derived classes specialization and base class is generalization. So specializes a single base class means the single base class will have one child, one specialization. So specializes a single base class. In multiple inheritance, derived class has more than one direct base class. So this derived class can have more than one base class. Creates complex hierarchy of classes. Okay, it will create complex hierarchy of classes. Possible multiple inheritance of members. Multiple members, you can say. Combines multiple classes. Like this derived class has combined base 1 and base 2. Same inheritance and access rules. The rules which are followed in single inheritance will be followed in multiple inheritance also. These access rules which we have learned. So in C++ there are different types of multiple inheritance possible. We have discussed single inheritance, we have discussed multiple inheritance. Third type is hierarchical inheritance. That means a parent can have multiple childs. A base class can have multiple derived classes. In multi-level inheritance means base class will have child, a base class will have derived, then that derived class will have another derived class, then that derived class will have another derived class. That is known as multi-level inheritance. Hybrid inheritance means mixture of all. See, a parent class has multiple child and this child have multiple parents, we can say, and it is also multi-level and it is also hierarchical, you can say. It is also multi-level, single and hierarchical. So hybrid inheritance. So this is an example of hybrid inheritance. Syntax for declaration of derived class. Syntax, we have already discussed the example of inheritance. So here syntax will be easy for you to understand. Here you can see a derived class name, colon, access specifier, base class name. This is how we inherit the base class. This is how the derived class inherits the base class, then the body of the class. So this is the simple syntax for the declaration of derived class. So here the example is given that here's the class A, this is the body of class A, here's the class B, colon, public A, means this class B is inheriting all the properties of class A as public, and this is the body of class B. Here class B is derived from the class B is derived. This class B is derived from class A. Here public access specifier defines how class is derived from base class, how class B is derived from base class A. Now let's see different ways of accessing base class members. So this example we have seen how the derived class can access the public members of the base class. Derived class cannot access the private members of the base class. So I'll try to run this program in the Turbo C, which we have discussed. This is the program. I'll compile it, run it. This was the expected output which we had seen. Now we know that this derived class cannot access the private members of the base class. It will not inherit the private members of the base class. Okay, whatever is public will be inherited as public, whatever is protected will be inherited as protected. Now here's a program, base class access control private. So this program we will continue in the next lecture. For today we will stop here.